Good everybody, Mastermind here again. So we'll have to talk about another important reaction in organic chemistry that also deals with carbonyl, and it's also important in organic chemistry. And that reaction is Cannizzaro reaction. Well, Cannizzaro reaction is a reaction between two non-enolizable aldehydes. It's a reaction between two non-enolizable aldehydes in the presence of a base, yes, in presence of a base to form a carboxylic acid and an alcohol. I'll come again, it's a reaction between two non-enolizable aldehydes in the presence of a base, a strong base actually, it can be sodium hydroxide, it can be hydroxyl radical, to form a carboxylic acid and an alcohol. Now the key points here in Cannizzaro is that it involves two non-enolizable aldehydes. Now, a non-enolizable aldehyde is an aldehyde that lacks an alpha carbon and as a result lacks an alpha hydrogen. I'll come again. A non-enolizable aldehyde is an aldehyde that lacks an alpha carbon and in turn lacks an alpha hydrogen. Now, there are only two non-enolizable aldehydes in chemistry, and they include formaldehyde, or what we call methanol, or methanol as the case may be, and benzaldehyde. Now, that's the first key point. The second key point is that it is a disproportionation reaction. Now, don't worry about the English, it's just grammar. What it means is that one of the aldehyde is going to be oxidized and the other one will be reduced at the same time. It is not a redox reaction, because in a redox reaction, oxidation leads to reduction. It doesn't typically occur at the same time. But here, for this proportionation reaction, it occurs at the same time. That as one is being oxidized, the other one is being reduced at the same time. So this basically means oxidation and reduction is occurring simultaneously. One of the non-enolizable aldehyde is being oxidized, the one is being reduced. Now, the next step that occurs in the presence of a strong base occurs using a strong base, such as sodium hydroxide. We also have hydroxyl radical, OH radical. These are the two most common that I like using a lot. Now, the next thing that you need to know is that the product of Cannizzaro reactions is one carboxylic acid and one alcohol. So if you are taking a CVT text, you should note this. These are possible CVT questions. And also, another thing you need to know is that Cannizzaro reaction is not a carbon to carbon reaction. It is not a carbon to carbon reaction. That it does not involve two carbon atoms forming a bond between them. If you are doing a CBT based exam, these are key points that you need to know. Now let's talk about the mechanism itself. I want to show you how we can get carboxylic acid and alcohol using two non-enolizable aldehydes. This is a Cannizzaro reaction between two non-enolizable aldehydes. So what we have here is formaldehyde. What we have here is also formaldehyde. That's carbonyl, that's methanol, an aldehyde. Now, the first thing that happens in the mechanism is this. The first thing that happens in the mechanism is this. Formation of a dianion through nucleophilic attack and deprotonation. deprotonation. Thus, two events must occur to form a dianion. There will be a nucleophilic attack first, and there will be a deprotonation step. Now, let's get right into it. Let's take one of the out there. Let's take this one. So we have the first one, we have HC double bond OH. Now, the nucleophile here is our base, which is OH. Minus or OH radical. Let's use that English. So remember, it's a nucleophile. Since it is a nucleophilic attack, it must be an attack between this nucleophile and this carbon. So I have taught you how nucleophilic attack works. There will first be a resonance stability between this. This will come here. We first form this. We have HCO minus H. Well, this is the resonance form of this. This is a movement of pi electrons, or pi electrons towards the more negative atom, which is oxygen. As a result, to create an electrophilic carbon that can undergo nucleophilic attack. So this nucleophile here will come and attack this. So we now have this as the product. You have HCO minus. You have O. Okay, let me put it here. You have OH, and we have H. This is not a product, but this is an intermediate that is needed to form the dianion. Remember, this is nucleophilic attack and then deprotonation. So when you hear deprotonation, which means you need another base, and that's why a strong base is needed, because strong bases can undergo nucleophilic attack and can also cause deprotonation. So we have to deprotonate this. That's remove a proton. Remove a proton. So let me draw it there. We have that product. We have HCO minus HOH in the presence of another base, OH. This base will remove this proton. This base will remove this proton. This hydrogen that is here, it will be removed as proton. This will come towards this, forming what we have, HCO minus H, then O. Remember, if this hydrogen leaves as a proton, it is dropping its electron behind. We now have the electron on this oxygen, then plus, if you add a proton to this, you have H2O, liquid. So this molecule has two negative charge, Abi. That's why it's called dianion. So this is the dianion products that you want to get from the first step. So remember, the first step is nucleophilic attack and deprotonation to form a dianion. So that's about the first steps. The formation of the carboxylate from the dianion by movement of pi electrons. When you see the word movement of pi electrons, it means there is a rearrangement to ensure more stability. So the dianion that we had was this HCO minus O minus H. This is the dianion. So what will happen here is this. You know, we formed a water at the second step. Molecule of water at the second step. And water is can be written as OH2, by the way. And oxygen still have 4 electrons in its outermost shell. Yes, 4 electrons in the outermost shell, pending the 2 used to bind with hydrogen. So what will happen is this. These 5 electrons here on this dianion will move towards the carbon, because double bonds are much more stable than single bond, because it wants to assume stability. It will move towards the carbon, and this will make the carbon eliminate this proton, this hydrogen here as proton. I'll come again. This pi electron will move towards the carbon, forcing the carbon to eliminate this, because if you move towards the carbon to have 5 bonds, if this one remains here, so carbon must always have 4 bonds. So to eliminate this hydrogen, as proton. That this hydrogen will be transferred to this water molecule. You now have this as a product. You have H, C, double bond O, then O minus, that's when it has been lost, then plus OH3 positive. This is what we call hydronium. What we call hydronium. So the hydrogen here is being lost as proton, transferred to this water molecule to form hydronium ion, and then this molecule that we have here, is what we have here is what we call carboxylate. It's called a carboxylate because it has a carbonyl carbon and a negative sign. So that's the second step. Formation of the carboxylate from a dianion by movement of pi electrons. And the reason why this pi electrons have to move is to ensure more stability, because double bond on carbons are much more stable than single bond. So this pi electron moves towards the carbon, forcing the carbon to eliminate this hydrogen. And this hydrogen is going to be lost as proton. That's going to be transferred to this water molecule, forming hydronium ion. This negative positive sign you see on oxygen, it means that it is not stable, because oxygen has a bond order of 2, but here it has 3 bonds, so it is not stable. So that's the second step. You see that we are almost getting to the end, and because I've gotten, remember our product is carboxylic acid and alcohol. We've gotten something that looks like carboxylic acid. Now we remain to get the alcohol. So that will be the third step. The third step is formation of an alcohol oxide by transfer of hydrogen from this hydronium towards we have 2 aldehydes. We've only used this one. We're going to transfer an hydrogen atom to this via nucleophilic attack. To form the alcohol oxide. So that's the next step. In this step, we want to form an alcohol oxide using a second aldehyde via nucleophilic attack. So we have the hydronium, we have the second aldehyde, which is this. Using the hydronium. Now what will happen here is this. Now the hydronium is not stable. That's one bond here has to leave. So one of the bonds here will be broken. Due to transfer, it will be broken, and an hydrogen atom will leave here. Remember, this bond is breaking to produce an atom, not a proton. So this hydrogen atom is leaving as hydrogen atom that has 1 electron in the atomic shell. That's an hydrogen atom that has 1 electron in the atomic shell. So that hydrogen atom there is acting as a nucleophile. It's acting as a nucleophile because it is leaving this place as the atom, not a proton. So remember how nucleophilic attack works, like I've been saying so far. This is going to move towards here, and then this hydrogen atom is coming to come and attack this. You now have this HCO minus, then we have H and H. This is what we call an alcohol oxide. And this alcohol oxide is for, and you can have the plus the hydroxyl radical back. This alcohol oxide is formed from nucleophilic attack of an hydrogen atom from the hydronium to the second aldehyde, forming an alcohol oxide. So we're almost done. Now the last step now is to just form the alcohol from the alcohol oxide and the carboxylic acid from the carboxylate, which is Cannizzaro reaction. So the last step is formation of alcohol and carboxylic acid from the alcohol oxide and carboxylate respectively. Now the last step for Cannizzaro is formation of carboxylic acid and alcohol respectively. Now remember we are using hydroxyl radical as the strong base. Now there's something you need to know is that hydroxyl radicals are reactive species gotten from water. So it means that they can accept proton and form water. And the water itself can also accept proton and form hydronium. So a water molecule in the medium, in the basic medium, will donate a proton. So this when this place, the water molecule will donate a proton here, donate a proton towards this oxygen. Remember, this hydrogen will leave as a proton. You now get carboxylic acid, which is this HC double bond O, then OH. Remember, if this guy leaves as a proton, what we have here is OH, and then the electrons that this hydrogen leaves behind. You now have plus OH radical, which is the starting base that we used before. And then, so this is the carboxylic acid. Carboxylic acid. Remember, this formation of carboxylic acid occurs by protonation. Now, for the second part, which is the alcohol, the same thing. The hydronium, which is formed when a water molecule accepts one more proton. The positive charge here shows that it's an ion. This water molecule donates a proton towards it. Remember, this proton is going to leave as it's going to leave behind its electron. That electron will neutralize this positive charge and to the neutral. So it's going to donate the proton to this molecule, forming HCOH, H, and H. This is basically what we call the primary alcohol or an alcohol. And then plus water. So this is the end product of Cannizzaro reaction, carboxylic acid and alcohol. So let me give you some practice question also. You know, I said there are two non-enolizable aldehydes. I've used formaldehyde. This is the second one. So some form of practice. So practice this. Practice. Write the mechanism of Cannizzaro reaction between two molecules of benzaldehyde, C double bond OH, plus another one, C double bond OH, in the presence of, you can also use hydroxyl radical as the base. So like I said, feel free to write it in your notes and send the answer in the comment section. Just follow the steps in this video and it is very, very easy. Those of you doing CBT exam, take note of the key points I gave in this video, and that's about it. Thank you for your time. Thank you for your patience. Thank you for watching. I remain Mastermind of M and Science. Have a good day, everybody.